before on popular demand. Today I am going to tell you the basic meaning of the terms LCM and HCF. Now I assure you one thing, that once you know the meaning of these two very important concepts of LCM and HCF, you won't require any method to find the LCM and HCF of numbers up to 100. So all you need to know is the tables and the factors. Now, to understand this, I will take two numbers and try to find the LCM and HCF of these two numbers by just understanding the meaning of LCM and HCF. Then we can take more examples to understand it in a better way. Now in LCM there is an alphabet M, and M stands for multiples. Now what are multiple? When you write table of a number like 7, 7 ones are 7, 7 twos are 14, 7 threes are 21. So 7, 14, 21, 28, 35 and so on, they are called multiples of 7. Likewise in HCF, the alphabet which is contained here is F, and F stands for factor. What is a factor? Suppose I have to find out the factors of 12. All those numbers in whose table 12 will exist. Like if we count the table of 2, obviously you will find 12 in that table. 2 6 are 12. So 2 is a factor of 12. Likewise, a number can have many factors. 6 is another factor of 12, because again 6 twos are 12. And always remember that 1 and the number itself are the factors of that number. Now suppose I have to count all the factors of 8, then I have to start from 1, then move on to 2 because 2 fours are 8, then move on to 4 because 4 twos are 8, and then finally end at 8 itself because 8 ones are 8. So understanding of multiple and factor is very important. Multiples are always greater than the number, like 8, 16, 24, we move in increasing order. And factors are always equal to or less than the number. Like the factors of 12 cannot be greater than 12. So it has to be a number which is smaller than 12. So multiples and factors. Now let me write the multiples of these two numbers whose LCM is to be found out. Now see 8, 16, 24, 32, 40. Now these are the multiples of 8. And similarly, if you write the multiples of 12, 12, 24, 36, 48, 60 and so on. These are the multiples of 12. So M stands for multiple, so I have written the multiples of both the numbers. Now what does C stand for? Now C stands for common. Here also C stands for common. So we are talking of multiples M, and what type of multiples? Common multiple. Now see, if you see what is common in this, 8 does not exist here, 16 does not come here, 24. Now see 24. Now 24 is a common multiple. Likewise, if you write this table further, you get another common multiple, say 48. It is a common multiple. So we are talking of common multiples, LCM. CM means common multiple. Now what does the final alphabet L stands for? L stands for least. Now obviously in LCM you have least common multiple. So L comes first, but for understanding the meaning you need to understand it in the reverse order. First the meaning of multiple, then what are common multiples, common multiples, and now finally you arrive at the answer once you come at the third alphabet, that is L. L stands for least. Least means the smallest. Now see, 24 is the smallest multiple which is common in both the tables. So LCM of 8 and 12 is 24. Likewise, if you want to understand this highest common factor, now you can do it in the similar fashion. Now see, I am writing the factors of 8. 8 comes in the table of 1, in the table of 2, in the table of 4, and in the table of 8. 12 comes in the table of 1, 2, 3, 4, 6 and 12. Now I have written all the factors of both the numbers. So F is done. Now come to the common part. Now what is common in this? See, 1 is common, 2 is common, 4 is common, and nothing else is common in this. So I have taken care of the second alphabet, common also. And now the final alphabet, that is H, highest. In LCM we were talking of least, that is the smallest. Now in HCF we are talking of highest. Now see the common multiples 1, 2 and 4, which is the highest? 4. So HCF of 8 and 12 is 4. Now see, we have not taken any method for finding the LCM, just the understanding of what is LCM. Now let us take one more example. Now suppose you have to find the LCM of 18 and another number, say 20. Now for 18 and 20 you need to write the table of 18, and if you have understanding of tables you will realize that in 18 you will carry on writing this table, but you will not get a 0 in the units place until you multiply this by 5. So 18 5s are 90. Then you will not get any number which is having a 0 in the units place. 18 10s are 180. Because in 20 all the multiples will have 0 in the units place. So I need only those numbers which have a 0 in the units place. So 20. Now after 20 I have 40, 60, 80 which cannot be common in this. So I have to write it up to, see, 40, 60, 80 is a, nothing is common. See, 100, 120, 140, 160, nothing is common up to what I reach 180. So the LCM of 18 and 20 is 180. See, little bit of understanding, and just by looking at the numbers 18 and 20 you can find the LCM of 18 and 20. Now suppose you want to find the HCF of two more numbers. Say we have 36 and we have 60. Now see, 36 and 60, if you write 36 as the factors as 1, 2, 3, 4, 6, 9, 12, 18 and 36. See, I have written all the factors of 36. Similarly, write the factors of 60. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. Now see, I have written all the factors of 60. Now just check which is the common factor. Obviously, start from here because we need to find the highest. So 60 is not common, 30 is not common, 36 is not common, 18 is not common, 15, 12. Just see 12. After 12 there is no common factor. Say 15, 18, 20, 30, 36, 60. There nothing is common here. So HCF is 12. Likewise, you can take some more examples yourself and try and find the LCM of some more numbers. Say suppose now I have to find the LCM of a number which is prime. Now see, suppose I have 11 and 14. Now for finding the LCM of 11 and 14, I don't need to write the tables also. Why? Because 11 is a prime number. Now whenever a number is prime, then it can have a common factor with the other number which is the same number. Now I can have 11 as a factor of the other number if it is this number is also divisible by 11, but 14 is not divisible by 11, so I don't need to write the tables. Just write the LCM of 11 and 14, which will be equal to 11 multiplied by 14, which is 154. Don't need to write the multiples of all these things. Now suppose both the numbers are prime, then our job is further simplified. Say LCM of 7 and 13 is just 7 into 13, because there cannot be any common multiples between 7 and 13 except the product of these two numbers. So 7 into 13 is 91, which is our answer. Now suppose there is a case in which the two numbers exist in the table of the smaller number. Now see, suppose we have 9 and 27. Now you don't need to find the LCM here, because least common multiple will be the smaller number only, because 27 comes in the table of 9. So LCM is 9 because 27 is divisible by 9. So whenever larger number is divisible by this, then the larger number itself is the answer. So you see, just by having the understanding of this basic concept of LCM, the meaning of LCM and the meaning of HCF, you can find the LCM and HCF in a very short time. See, when we talk of LCM, it involves the letter M, and M means multiples. See, multiples of 3 are 3, 6, 9, 12, 15 and so on. And if you take another number, say 7, so multiples of 7 are these. Now see, when you talk of LCM, we need to find a number which is common in these multiples. If you have to find the LCM of 3 and 7, so LCM of 3 and 7 will be that number which is a common multiple, and the first common multiple will give you the LCM. Now see, what is common in this? 21 comes first, which is the common multiple. So 21 is the LCM of these two numbers. Now the important point to understand here is that the LCM of two numbers is always greater or equal to the numbers. Now see, the numbers are 3 and 7 and LCM is 21. So 21 is much greater than 3 and 7. So LCM is always greater than the numbers whose LCM is found out. Now when we talk of HCF, it involves F. F means factor. Now if you write the factors of 12, say 1, 2, 3, 4, 6 and 12. Now these are the factors of 12. That means the numbers which divide 12 exactly. And again, suppose we have 15. So the factors of 15 are 1, 3, 5 and 15. So these are the factors of 12 and 15. Now see, when we talk of highest common factor, now what is the common factor? 1 obviously will be common, so we don't consider that. See, 3 is common here, so nothing else is common. So HCF of 12 and 15 is 3. Now see, another important point, take home message. Now this message is that the HCF of two numbers is always less or equal to the original numbers. Very important difference between LCM and HCF. LCM is normally greater than the original numbers and HCF is normally smaller than the original numbers, because obviously the factors have to be smaller than the numbers. Multiples are always greater. Now if you have understood this concept, we can take up two problems and sort out why concept of LCM or the concept of HCF is used to solve that problem. Now suppose I am taking problem 1. Now in this problem we have a circular garden and there is a starting point from which two persons A and B are starting to move around this circular path. A is taking 18 minutes to go once around this circular path, whereas B is taking only 12 minutes to go around the circular path once. Now we need to find after how many minutes these two persons will be at the starting point together. Obviously they are starting at the same point at the same time, but they are taking different times to cover this entire circumference once. So we need to find out after how many more minutes they will be together at the same point, starting point again. Now see why the concept of LCM will be used in this question. If A is taking 18 minutes to go around once, then obviously the time taken for both of them to reach this point again will be greater than 18 minutes. So I told you LCM is always greater than the original numbers. Now we need to find the answer here. That answer has to be greater than 12 and 18. So the concept of LCM has to be used here. Little bit of understanding and little bit of practice of these types of question will enable you to very easily interpret that concept of LCM has to be used in this question. So 12 and 18, if you want to find the LCM, see larger number is 18. I have discussed some shortcuts to find the LCM and this is the simplest method to solve the problem of LCM now. Now 12 and 18, 18 is the larger number, but 18 is not exactly divisible by 12. So just take multiples of 18. 18 to the 36. Now check 36 is divisible by 12 or not. Yes. So answer is 36. So solution, that 36, after 36 minutes these two persons will be at the starting point again. You can very easily verify 18 minutes. So A will complete 2 rounds of this circular path. 12 minutes, 12 3 is 36. So B will complete 3 rounds. So after 36 minutes they will be here again. So concept of LCM, whenever your answer is more than the original numbers. Now one problem involving the concept of HCF. Now why the concept of HCF is to be used. See problem 2. Now suppose there are 3 subject books. Now suppose there is a subject A, subject B and subject C, and there are separate number of books of each subject. There are 96 books of A, 240 books of subject B, and suppose 336 books of subject C. Now we need to arrange these books in stacks. Obviously one stack will contain only one subject books. So we need to find out the number of books in one stack so that exact number of stacks are formed in 96 books. Same number of stacks say for 240 books and same number of stacks for 336 books. So the number of books in the stacks have to be same. Okay, like now see, if 96 books have to be arranged in stacks, then obviously number of books in one stack will be less than 96. Same number of books have to be there for B subject books and for C subject books. Same number of books in one stack. So that number of books in one stack cannot be more than the original number of books obviously. So the answer has to be smaller than the original numbers. So once you understand this, that your answer has to be smaller than these numbers, then automatically you can say to yourself that yes, concept of HCF has to be used in this, because HCF is always smaller than the original numbers. So now you need to find the HCF of these three numbers. Now for finding the HCF, obviously you have different methods, prime factorization method, and you can use Euclid's division lemma also for finding the HCF of these. Through Euclid division lemma, obviously that long division method is used. So I am using factorization method. I know that 96 is 48 into 2, 240 is 48 into 5, and 336 is 48 into say 7. 7 8s are 56, 6 5, 7 4s are 28, and 3 5 33. So see, 2 5 7, they are all prime numbers, so 48 is the common factor, so the answer is 48 books. That means stacks of 48 books have to be made. Now 48 into 2 96, so 2 stacks, 48 into 5 240, 5 stacks, 48 into 7 336, 7 stacks. So very important point here is that LCM of numbers is always greater than the original numbers, and HCF of numbers is always smaller than the numbers. And this concept can be applied in case of LCM and HCF problems involving statements. So keep learning, keep enjoying, and share and subscribe the channel if you like it.